Now we're going to turn to Cournot Competition. This is our final model for oligopoly. And in Cournot, what we're going to see is, again, a few firms who are responding strategically to one another. This time, again, they are competing, so there's no cooperation, and they are competing on the margin of output. So in Bertrand, the previous model, firms were competing on the price margin. Now, with Cournot, they're competing on the quantity margin. So they're choosing how much to produce, and in that way, try to take whatever portion of the market maximizes their profit so that their competitor can't, right? Market participants are only going to purchase so much. And the Cournot firm wants to capture the number of those consumers that maximizes their profits. Okay. For our Cournot model, we're again assuming that they make identical products. Of course, we're assuming that they compete by choosing how much they produce. All of their goods are going to sell for the same market price, so all of the firms face the same price, and that's going to be determined by the total output in the market. So we're going to add the output of all the firms together. That gives us our market output, and that then is going to determine the price based on the market demand curve. And then finally, we're going to have all of these firms choose their output simultaneously. So they're going to try to estimate what their competitors are going to produce. They don't know for sure. And they're going to select their own output based on that estimate of their competitor's output. Mathematically, what we're going to see is that the firm's profit depends on what their competitors produce. And so they're going to have what we call a reaction curve. Each firm is going to essentially take some portion of the market demand. It's going to depend on what they think their competitor is going to produce, and that will determine how they produce. All right, so you can see in the graph here, Iran and Saudi Arabia are both producing oil. Iran's reaction curve is shown in orange, and it's given by Q sub I equal to 30 minus 1/2 times the amount that Saudi Arabia produces. And Saudi Arabia's reaction curve is shown in yellow, and it's given by the equation, the quantity that Saudi Arabia produces equal to 30 minus 1/2 times the amount Iran produces. Where those two curves intersect, where they are equal, is going to define for this market, define for each of these producers, how much they make. All right, so when we solve this problem in just a second, we're going to see that both firms are operating at this point E, this point of intersection between the two curves, meaning that they're both going to be producing 20 million barrels of oil each day. All right. Before we get to that example, let's go back one slide and think about OPEC. All right, so OPEC, these companies are selling to the world market. This is an example where we can think through how if Saudi Arabia sort of floods the market with oil, lots of the consumers are going to consume that cheap Saudi Arabian oil. All right. But Saudi Arabia doesn't necessarily want to do that because doing so lowers their market price. And so they want to keep their output at a level relative to Russia and other members of OPEC such that their profits are maximized, right? They want the market price to stay sufficiently high such that they earn good returns, okay? So as they estimate their competitors' output levels, that left over, that portion of the demand curve, what we call a residual demand curve or residual marginal revenue curve, is going to become for the monopolist their own market output. So their own market demand curve. So there's some portion of demand that's essentially being allocated to Saudi Arabia, and they're going to treat that part of market demand as if it is the whole market demand, okay? So when we get to the math, you'll see that, right? They're going to define their marginal revenue only with regard to their own output. All right, so let's go ahead and turn to that example. All right, so we'll stay on this slide and then we'll go ahead and switch over to the notebook. Okay, so looking at our example with these Cournot firms, I don't believe we were given their market output yet, so let me go ahead and pull it up. So for Iran and Saudi Arabia, we're going to say that they're, just for this problem, the only two countries that supply oil to the world. All right. And so we want to see what they produce when they operate as Cournot firms. Okay, engage in Cournot competition. Okay. The market demand for oil is going to be given by quantity demanded equal to 65 minus the price over 4. Total market output is going to be the amount produced by Saudi Arabia plus the amount produced by Iran. And their total cost is going to be 20 times output. Okay, each is having the same. What we want to do is find, of course, how much each of our firms produces, right? That's how they compete with each other, is on that margin of output. Then we want to find the price that will prevail in the market as a result of each of their production decisions. And then finally, we want to know how much profit will each of our firms make. Okay, so those are the 5 values we want to solve for. And we're going to start by solving for output. So first things first, we want to transform the market demand curve such that it is solved for price, right? We want to have that inverse demand function. So we'll go ahead, let's rewrite our given demand equation. So quantity equal to 65 minus the price over 4. We're going to add price over 4 to both sides and subtract quantity such that we get price over 4 equal to 65 minus Q. Then we're going to multiply both sides by 4. Okay. That's going to give us 260. So we'll have price equal to 260 minus 4 times the market output. Now, as part of this problem, we're given that market output is equal to the sum of production by each country, right? So we can go ahead and substitute for market quantity here, such that our market demand equation is going to be price equal to 260 minus 4 times the quantity that Saudi Arabia produces plus the quantity that Iran produces. From here, we'll distribute that -4. So we'll have into the parenthetical. So we'll have price equal to 260 minus 4 times the amount produced by Saudi Arabia minus 4 times the amount produced by Iraq. Now we have a version of the market demand curve that we can work with to identify how much each firm produces. Okay. So like we said, each firm is going to derive from the market demand equation a marginal revenue curve to represent which portion of the market they're going to be serving. Okay. So we're going to follow a similar process to that of monopoly. When we are finding marginal revenue. But it's going to be very important that we keep in mind which firm, or which, in this case, country, we are solving for, okay? Because the coefficient that we double is going to be the coefficient on that country's quantity variable, okay? Hopefully you're paying close attention. because this is something that students often get confused about, right? I'm gonna repeat it. Firms who are engaging in Cournot competition, in this case, we're looking at the two countries, Saudi Arabia and Iran, they are carving out for themselves a portion of market demand, which we call the residual marginal revenue curve, right? Or residual demand curve. That means that when they are identifying their marginal revenue equation, they'll follow a process similar to the monopolist because they want to act as a monopolist for that portion of market demand. But it means that when you are transforming the market demand curve mathematically into the marginal revenue curve, you have to be very careful about which coefficient you double. You're going to double the coefficient that is modifying the quantity variable for the firm whose marginal revenue equation you're deriving. Okay, so let's do this an example and you'll see very clearly what I mean. So let's start with Saudi Arabia. So we're going to start by finding the marginal revenue curve for Saudi Arabia. That's going to mean that we're going to double that coefficient on Saudi Arabia's quantity variable in the market demand curve. So we'll get that the marginal revenue for Saudi Arabia is equal to 260 minus 8 times the quantity produced by Saudi Arabia minus 4 times the quantity produced by Iran. So you can see we only doubled the coefficient on the Saudi Arabia's output variable, right? We only doubled the coefficient modifying Saudi Arabia's output variable. Okay, we're going to do the same thing for Iran. So for Iran now, right, when we find their marginal revenue, we're going to double the coefficient modifying their output variable. So we get that Iran's marginal revenue is equal to 260 minus 4 times the quantity produced by Saudi Arabia minus 8 times the quantity produced by Iran. All right. Notice again, we left the coefficient modifying Saudi Arabia alone, and we only doubled the coefficient modifying Iran's output variable. All right. Now, each of our countries, each of our firms has their identified residual marginal revenue equation. What we're going to do from here is treat them as if they're monopolists. So they're going to produce where their marginal revenue equals their marginal cost. Okay, so we'll have both producing where their marginal revenue equals their marginal cost. And we were given that each had a total cost of 20 times Q. They had the same total cost equation. That means that their marginal cost then is going to be the same, right? When we take the derivative of that total cost equation with respect to quantity, this is a Q. We find that both of their marginal costs is constant at 20. So for Saudi Arabia, we're going to have their marginal revenue equal to their marginal cost. So we'll have 260 minus 8 times the quantity that Saudi Arabia produces minus 4 times the quantity Iran produces equal to 20. Okay. And similarly for Iran, we're going to have their marginal revenue equal to their marginal cost. So we'll have 260 minus 4 times the quantity Saudi Arabia produces minus 8 times the quantity Iran produces equal to 20. All right. And so from here, we're going to solve each of these equations for each country's quantity in turn. So on the left, we're going to focus on identifying Saudi Arabia's output formula. And on the right, we're going to focus on identifying Iran's output formula. We're going to start with Saudi Arabia. So I'm going to subtract 20 from both sides and add 8 times the quantity produced by Saudi Arabia. So that gives us 240 minus 4 times the quantity Iran produces equal to 8 times the quantity Saudi Arabia produces. Next, we're going to divide both sides by 8. So we can represent that here. 240 divided by 8 is going to give us 30. -4 divided by 8 is going to give us -1/2 multiplied by Iran's output equal to Saudi Arabia's output. So what we found here is Saudi Arabia's reaction curve. We did something similar in our Bertrand problem earlier. And what it's showing us is that Saudi Arabia's output depends on what Iran produces, right? Which is the fundamental assumption underlying Cournot. Each firm responds to the output of the other strategically by changing their own output. Okay, let's do the same now for Iran. So we're going to add 8 times the quantity Iran produces to both sides. And we're going to subtract 20 from both sides. That's going to give us 240 minus 4 times the amount Saudi Arabia produces equal to 8 times the amount Iran produces. From here, we're going to divide both sides by 8. That's going to give us 30 minus 1/2 times the amount Saudi Arabia produces equal to the amount that Iran produces. So you can see here that their reaction curves are symmetric, right? For Saudi Arabia, their output is equal to 30 minus 1/2 times the amount Iran produces. And for Iran, their output is equal to 30 minus 1/2 times the amount Saudi Arabia produces. Okay. All right. And the reason they're symmetric is that they have the same marginal costs. Okay, so this is Iran's reaction curve. If they had different marginal costs, we would see that their reaction curves wouldn't be symmetric, right? They would be quite different. But in this example, they have the same marginal costs, and so we have symmetric reaction curves. Next, what we're going to do is we want to find how much each produces specifically, right? So what we need to do in Saudi Arabia's reaction curve is find a way to make this output by Iran equal to the output by Saudi Arabia, right? So essentially we need to get only one variable in this reaction curve, and that is the output that Saudi Arabia makes. What we're going to do is substitute for Iran's output using its reaction curve, okay? And that's going to allow us to identify exactly how much Saudi Arabia makes. So let's go ahead and make that substitution. So we'll have that Saudi Arabia's output is equal to 30 minus 1/2 times the amount produced by Iran, which we found is equal to 30 minus 1/2 times the amount produced by Saudi Arabia. So you can see now in our equation, we only have one variable, and that is the output produced by Saudi Arabia. From here, we're going to simplify. So we're going to distribute this -1/2 into our parenthetical. That's going to give us the quantity produced by Saudi Arabia equal to 30 minus 15, right? -1/2 times 30 gives us -15. And then we'll have -1/2 times -1/2. That gives us +1/4 times the output of Saudi Arabia. Our value for Saudi Arabia on the left-hand side, there's a 1 modifying that. I want to transform that 1 so it has 4 in the denominator. So I'm going to multiply it by 4/4. That's going to give us 4/4 times the quantity produced by Saudi Arabia equal to 30 minus 15 plus 1/4 times the quantity produced by Saudi Arabia. Okay. From here, I'm going to simplify 30 minus 15, as well as subtract 1/4 times the amount produced by Saudi Arabia from both sides. That's going to give us 3/4 times the quantity produced by Saudi Arabia equal to 15. From there, we'll multiply both sides by 4/3. So that output produced by Saudi Arabia is going to be equal to 15 times 4/3. 3 is going to go into itself once and into 15 5 times. So we get output produced by Saudi Arabia equal to 20 million barrels of oil. Now we need to find how much Iran makes. Luckily, we have this handy-dandy formula that states Iran's output in terms of Saudi Arabia's output. And we've just found that Saudi Arabia's output is equal to 20 million barrels. So what we can do is just substitute directly for Saudi Arabia's output. That's going to give us that Iran's output is equal to 30 minus 1/2 times 20. Simplifying, we get 30 minus 10. And so, Iran's output is going to be just the same as Saudi Arabia's at 20 million barrels, right? Which is what we predicted from that graph in the previous slide. Right. So we found the amount produced by each firm, and it is 20 million barrels of oil. Next, we want to find the market price. To find the market price, we need to find the market output. And remember that market output is equal to the sum of our two firms' production. So both are producing 20 million barrels of oil, so market output is going to be 40 million barrels. Now that we know market output, we can find the price by substituting for that market output in our demand equation. So we'll have price equal to 260 minus 4 times market output. That's what we're given. And we're going to go ahead and substitute for quantity. So we'll have price equal to 260 minus 4 times 40. That's going to give us 260 minus 160. So the price for each barrel of oil is going to be $100. We're almost there. Last thing we want to do is find the profit that each of our firms make. So let's go ahead and use that same profit equation that we've been using. So the profit for Saudi Arabia is going to equal the price minus their average total cost multiplied by their output. Okay. We were given that their total cost is equal to 20 times Q. Average total cost we know is just total cost divided by output. So we get 20 times Q over quantity, and we get that their average total cost is 20. So we found then that price is 100, so we substitute that in. We just found that average total cost is 20, so we substitute that for average total cost. And we found that Saudi Arabia produces 20 million barrels. So for their profit, we have 100 minus 20 multiplied by 20. That gives us 80 times 20, which multiplied together gives us 1,600. And note that this 20 is in millions, quantities measured in millions, so it's actually 1.6 billion. All right, so we can rewrite this as, there we go. So Saudi Arabia's profits are $1.6 billion. Let's do the same for Iran. So Iran, they face the same market price of 100. They have the same average total cost of 20. And we know that their output is also equal to 20 million. So you should see there very clearly, right? Their profit is going to be the same as Saudi Arabia's. Okay. Note that the fact that both Iran and Saudi Arabia, one, make the same amount and earn the same in profit is because they have the same total cost equation, meaning that their marginal costs and their average total costs are the same, right? If they had different total cost equations, if they had different marginal cost equation, if they had different average total costs, then their output and their profits would not be the same, okay? So just because in this example they were the same, you can't assume going forward that they're always going to be identical, all right? All right. With that, let's go ahead and go back to our slides. So one additional thing we want to talk about with Cournot. So far we've only talked about if there are two firms in a Cournot market. What is going to happen if we have more than two? So in this market, what we see is as the number of firms increases, each of those firms is taking on a smaller share of market output, but they're also each trying to produce as much as they can. And so the firms are going to, through that competition on the output margin, increase quantity such with the number of firms in the market, such that the market approaches what a perfectly competitive level of output would be. It will never get there, right? Because that'll make the firm's profit zero. But as more and more firms join that market, they're going to asymptotically approach profit of zero, such that it essentially looks like a perfectly competitive market, but it will never actually get there. As that quantity increases with the amount of firms in the market, what we're going to see is that the market price is going to fall. And similarly, it's going to approach that perfectly competitive level of approaching the firm's marginal cost, but it's never going to actually get there. Okay. And so what that means then is that the industry profits and subsequently the profits earned by each firm are going to approach the perfectly competitive level, meaning they're going to fall and they're going to approach zero. Okay. So when it comes to oligopoly, the three models that we've evaluated with Cournot, if you have more than two firms, and if those number of firms in the market is able to increase, we're going to see market outcomes that approach perfect competition, right? They're not going to deviate very far from it. And so situations of oligopoly from a consumer's perspective should not be that objectionable, right? The price is going to be a little higher than it would be if the market was perfectly competitive. There's going to be a little less output, but the difference is not going to be so significant like we would see with a monopoly, such that consumers are going to be bearing a much higher price burden or foregoing much in terms of consumption. With Bertrand, all you need is two firms in that oligopic market, and you get exactly the perfectly competitive output. And then finally, for collusion, while those firms are trying to cooperate and operate as if they were a monopoly, that incentive to cheat is going to fundamentally undermine it. And so any collusion or cartel is not going to last very long. And so as a result, consumers are in the long run, likely to face a market that is close to, if not identical with, the perfectly competitive market. Okay. Obviously, there's some nuance in there as we apply the models to the real world. But when we think about policy, especially antitrust policy, and especially when people speak about concerns about oligopoly, there's really no reason why we would expect a market dominated by only a few firms to diverge very much at all from the perfectly competitive market predictions, right? Prices will likely be close to their marginal costs, and output is likely to be very close to what they would make if they were pricing according to marginal costs. Okay. And so setting aside any barriers to entry like those that come from government, we really don't need to worry about regulating those types of markets in a way to make them quote unquote competitive, right? Because as long as there is the potential for new firms to enter and compete with the oligopoly firms, we're likely going to see outcomes that are competitive, right? And so just something to keep in mind, especially as going forward, I'm sure you'll see many times in your life, people object to the fact that a few firms are dominating a given market, right? People do this all the time with industries where they trace back lots of goods to just a few producers, right? And they say, oh, it's an oligopoly because there's only 6 firms making all these goods. Based on our models, that really should not be something that we're worried about, right? Even though there are only, say, 6 firms in a market, we're still going to expect, and this is something you could test very well. So if you ever take econometrics, this is something where you could try to get this market data and test this to see if it holds out. But we should see that those firms output the amount they produce, as well as the prices that they charge, should be one, price should be very close to the marginal cost, and two, output should be what we would expect given that they produce, excuse me, that they price where their price equals marginal cost. Okay. Um, that would be a prediction coming from this theory, which we could use econometric tools to test. All right. Just to give you a little insight into how we use these models, how economists use these models professionally, this is that, right? We say, what would we expect to see in this market if it was an oligopoly compared to what would we expect to see if it was perfectly competitive? And then we test based on given market data to see where it actually lies. All right. So with that, we're going to finish up with Cournot. And then in the last and final video of this lecture series, we're going to compare the market outcomes of the three models, Collusion, Bertrand, and Cournot. We're going to compare their market output, their market price, and the total profits in the industry.